Subdivision surface modeling is a technique used to create smooth, flowing forms, things like characters, creatures, or even the soft padding of furniture. In this example, the seat cushion on this office chair is an active open subdiv object, meaning I can freely adjust its level of detail while keeping its overall shape intact. While the rest of the chair's parts have already been baked down or converted to an editable poly, even though the bottom of the seat cushion looks round and refined, it doesn't appear to have dense wireframe. That's simply because of the current display mode. Let's take a closer look. So let's select that seat cushion, and then we'll go over to the modify panel. Here we can see its modify stack. At the base is an editable poly object, right there. Above that sits a symmetry modifier, which mirrors one side of the model to the other. So we only need to model half of the cushion. And at the very top, there's an open subdiv modifier. Let's toggle the visibility on and off so we can see what's happening. So this modifier subdivides the mesh into smaller polygons and averages their angle to smooth out any sharp edges or corners. Turn that off, we can see that here. If we disable the top modifier by clicking its visibility icon like we have, we reveal the original low poly mesh underneath. So what's often called as a control cage. So this cage isn't meant for rendering or exporting. It's a structural framework used to sculpt the smoothed surface. Great. So let's go and re-enable Open Subdiv. Cool. If you like to actually see these subdivided polygons, turn off Isoline Display. That can be found right over here. Untick that. Cool. So now you can view all the new geometry generated by the subdivision process. Now the most important setting here is the iteration value. This controls how many times the mesh is subdivided. That's here. So each iteration multiplies the number of polygons increased detail. You can track this live using polygon statistics. So press 7 to toggle that on. Make sure statistics for selected objects is enabled in the viewport configuration menu. Cool. So now as we reduce the iteration count using the spinner, let's go over here. An iteration reduction makes it a lot more chunkier. Can you see that? So when we reduce that, in the open subdiv, it's getting divided less, which makes, and then if you increase it, it gets much, much smoother. But too many subdivides can be overkill and just makes your file much too heavy. 2. Yeah, looking good. Alright, so if your base mesh is built from quads, each subdivision level will multiply the total polygons by 4. Usually an iteration value of 2 or 3 is ideal. Any higher, like 4 or 5, produces unnecessary density that doesn't improve visual quality and only slows performance. Like I said, it's a bit of an overkill. So we'll keep it at 2, which gives us a good balance between smoothness and efficiency. Bring that right down. Perfect. Now, subdivision surfaces have existed in 3ds Max for quite some time, and the implementation has evolved as the software improved. Among available tools, Open Subdiv provide the best performance and compatibility. It's based on Pixar's Open Subdiv standard, which ensures interoperability with other 3D applications. So it's quite developed. You'll even find other subdivision modifiers in the list. So like Mesh Smooth, Turbo Smooth, and HSDS, short for Hierarchical Subdivision Surfaces. They'll all perform similar tasks, but Open Subdiv is faster, cleaner, and more modern, so it's the recommended choice. If you ever see older tutorials using other modifiers, just substitute them with Open Subdivision instead. Awesome, so in understanding that, subdivision tools are also integrated into Editable Poly and Edit Poly modifier under the NURBS, short for Non-Uniform Rational Mesh Smooth. That built-in option can be handed for quick edits, but for most workflows, the Open Subdiv modifier offers greater control and flexibility. And that's the core idea behind subdivision surface modeling, and how it's applied within 3ds Max to create smooth, sculpted, and high-quality surfaces. Thank you so much for watching today. We'll see you in the next lesson.